Hello everyone and welcome back to the series. In the previous video, we talked about why mathematics is important for zero-knowledge proofs and cryptography. Today, we are going to start with one of the most fundamental concepts of mathematics: variables, expressions, and equations. At first, the topic may seem simple, but don't underestimate it. Almost every cryptographic protocol and zero-knowledge system is ultimately built from mathematical equations. If you look at a ZK circuit, what you'll find underneath are variables connected together by equations and constraints. So before we learn about modular arithmetic, finite fields, or cryptographic protocols, we first need to understand the language mathematics uses to describe problems. Let's start with variables. Variables. A variable is simply a symbol that represents a value. Usually, we use letters such as x, y, or z. For example, x equals 5. Here, x is a variable and its value is 5. Think of a variable as a box. The box has a name and inside of it is a value. For example, age equals 25. The variable is called age. The value stored inside it is 25. Variables are everywhere in programming, and they are everywhere in cryptography as well. For example, imagine I have a secret password. In mathematics, we can represent that secret with a variable. Secret equals 1, 2, 3, 4, 5, for example. Instead of writing the actual secret, every time we simply use the variable name. This idea appears constantly in cryptography and zero-knowledge systems. Expressions. Now let's talk about expressions. An expression is a combination of values, variables, and operations. For example, x plus 5. This is an expression. Notice that it does not have an equal sign. It is simply describing a calculation. Another example, 2x, or let's say 2 times x. In mathematics, writing 2x means 2 multiplied by x. Another example, x squared plus 3. This is also an expression. Expressions are used anywhere in cryptography. For example, if x represents a secret value, then x squared means take the secret value and multiply it by itself. Many cryptography systems perform calculations on secret value without revealing them. Equations. Now let's talk about equations. An equation is simply a statement that says two things are equal. For example, x plus 5 equals 12. This equation tells us that whatever value x has, when we add 5 to it, we get 12. Let's solve it. We want x by itself, so we subtract 5 from both sides. X plus 5 minus 5 equals to 12 minus 5. Which gives 7. So x equals 7. Let's verify it. Replace x with 7. 7 plus 5 equals 12. The equation is true. Why equations matter in zero knowledge? Imagine I claim that I know a secret value. Let's call that value x. I also claim that x multiplied by x equals 25. The secret value could be 5 or negative 5. A zero-knowledge proof allows me to prove that I know a valid value for x without revealing what x actually is. Notice something interesting. The entire problem is represented using an equation. This is exactly how many ZK systems work. They transform a problem into equations and constraints. Then they prove those equations are satisfied. That's why understanding variables and equations is so important. Let's look at another simple equation. Y equals x plus 10. Suppose x equals 5. Then y equals 5 plus 10, which gives 15. So y is 15. Here we have two variables that are related through an equation. As we move deeper into cryptography and zero-knowledge proofs, we will build larger systems made from thousands or even millions of these relationships. But the core idea stays exactly the same. Variables represent values, expressions describe calculations, equations describe relationships between values.